All right, we'll start off with some partial motion. Yes. You don't have the student. This is yeah. All right, we'll start with the partial motion problem here. Okay. So since velocity of a function is described as v of t, so in this case, the position is not given to us. We're starting directly with velocity. So just know that normally sometimes the problem starts us off with velocity. If that's the case, then now we only know how to go from position to velocity to acceleration. So if we're at velocity, we don't know how to go back up to position. That's next semester. Okay, we don't know how to. We only know how to go down the derivative chain. We don't know how to go up that chain until next semester. Okay, so it says velocity is given by v of t. So that means any time value that I give this equation, in return, it'll give me velocity, but I can also ask or give it a velocity and ask for the time. So remember, there's always that time velocity relationship. I can give it one and ask for the other. Okay, so part A says find the time when the acceleration is 0. So before we can do anything, we first have to figure out what the acceleration is, right? So how do I get from velocity to acceleration? Yes, derivative. Yep. So my acceleration is just a derivative, one derivative down from velocity. Okay, 1/3 t cubed. What does that turn into?
3 times 1/3 to the t second.
Yeah, good. So
1 or t to the second.
I'll clean that up later. Minus 4t plus what? Plus 3. All right, so what do we do with this acceleration equation here? Well, yeah, so we set equal to 0. So this is a little different than finding the acceleration at 0 versus when acceleration is 0. Do you see that? It's just that slight change in wording means something different. Acceleration at 0 would mean that I'm plugging 0 in for t. Acceleration is 0 means my acceleration variable is 0. So pay attention to those really those keywords there. So now that I'm here, what would you do next?
Minus 3.
Well, factor. Yeah, we got to factor, right? What adds it to be? Well, sorry, what multiplies to be 3 and adds it to be -4.
3 -1.
So we have our answers at 1 and 3. Now they don't. The problem doesn't specify the time, the unit for time, but let's assume it's seconds. T equals 1 and t equals 3. Now, if the problem doesn't give you time unit and it doesn't ask you for time unit, you're not expected to know what the time unit is. Okay. But the problem gives it to you and it asks you to for units of measure, then you got to make sure you provide it.
So it's your answers.
Yeah, we have 2 different. That's right. So there's 2 different times when acceleration is 0. Yeah, t equals 1 and t equals 3. So now part B, find the velocity when acceleration is 0. So what can we do from here? Separately into the velocity function, right? Okay.
you can play 1 or 3, right?
It's a both. We got to do both,
Oh.
right? Find what the acceleration when the acceleration is 0. So there's 2 times when acceleration is 0. So we're looking for 2 different velocities when acceleration is 0. Okay, number 2, position of the particle is moving along a straight line. So this is a particle motion problem where this object is just moving. It can only do 1 of 3 things, right? It's either moving left, moving right, or it's motionless. Okay, we have restriction here. T is greater than 0. Okay. When is the particle at rest? So what does this mean?
When x is 0.
What's 0?
X is 0.
Not when x is 0. When something else is 0, though.
Velocity.
When velocity is 0, right? Velocity 0 means particle is at rest. So we have to first find velocity, and then we have to set velocity, replace velocity with 0, and then we can solve for t, right? Because ultimately we're looking for the word when indicates we're looking for t when v of t is 0. So let's find velocity. In this case, we are given the position function. So sometimes position can be x of t, can be s of t, can be h of t. In this case, they say x of t because we're actually moving along the x-axis. So that's why they give it the x of t. All right, so what's the derivative? What's velocity here? What's your next step? Yeah, replace v of t with 0, right? Not t with 0, you're replacing v of t with 0. So I can actually take out a GCF here, take out a 3. Multiplies to be 8, adds it to be -6. -2 and -4. 2 and 4, right?
And you're able to keep both of those answers too.
I'm sorry?
You're able to keep both of those answers too.
We'll keep both of them that's because they're both t values greater than 0. So now part B, it says when is a particle moving right, and then when is a particle moving left. All this we can find using a velocity sign line. So if we create a velocity sign line, we can test intervals, and then each interval will tell us whether it's moving left or moving right. So we're going to create a velocity sign line. Now here, why do I want to put a 0 here? Yeah, because that's my boundary, right? If it says for all real numbers, then I can have my arrows going left and right. But here, there's an obvious stopping point, or beginning point rather, at 0. And then I can label this v of t. And I'll put 2 and 4 on my velocity number line. So we know that 0 is a boundary. 2 and 4 are places where my object or my particle is at rest. So we know that there must be some motion going on in each of these 3 intervals. And also, there's going to be a consistent motion. From 0 to 2, it's only going to go in the same direction. And 2 to 4, it'll only go in the same direction. And from 4 to infinity, just go in the same direction. Okay, so what number can we test to help us decide what's happening with this particle?
1.
Yeah. So 1, 3, 5. Now you don't have to test these numbers, but any small number that's closest to 0 is typically the easiest numbers to test. Now you could choose 6, you could choose 2.5, you can choose 1.6, but obviously these are the easiest numbers to plug in. Now, there's a lot of options here. You can plug into this velocity function, you can plug into something that's halfway factored, but my preference is put it into the fully factored form, because that way you can get to your sign a lot faster without having to do calculations. You can just figure out what the sign is without having to worry about, wait, what's 3 times 3 squared minus 18 times 3, right? That's a lot of calculation. Here, we can just gather what the signs are and get to our value, or we only care about the sign a lot faster. So I plug 3 in for t. 1 minus 4 is, just tell me if it's positive or negative. Negative. 1 minus 2 is negative. Now 3 has no impact, so negative times negative is positive. So I know that this object is going to move to the right for that in that first 2 seconds. Okay. If I plug 3 in, 3 minus 4, 3 minus 2, 3 minus 4 is negative. 3 minus 2 is positive. Negative times positive is negative. So there's a change in direction here. And then if I plug in 5, positive, positive.
We change this 3 times or 2 times.
2 times. That's right. It starts at 0. It moves to the right. It stops at 2 seconds. It turns around, goes left for another 2 seconds. It stops, turns around, and moves to the right. So this problem doesn't ask us when the particle changes direction, but if it did, we can say 2 times, right? 2 and 4 seconds, because the velocity changes signs. So it says, during what time interval is the particle moving to the right? What would you say?
0
to 2.
and 4 to 5.
And then union or comma, 4 to positive infinity. And the reasoning is because velocity is greater than 0.
But you know it's positive in the video because you don't know what's going to be. You don't know if it's going to change direction later on.
Well, we found all the candidates here. If there were more candidates, then when we set velocity equal to 0, we'll be able to find more t-values. But since there are no more t-values, that means there's only 2 places during this entire trip that this particle is going to change direction. So if it did change direction, we'll have to find it here. Okay. Okay, so during what time interval would the particle move to the left? 2 to 4, because velocity is less than 0. Now, why do we use parentheses for all these?
These numbers aren't included, they're at rest.
Right, at rest, right, at rest. So it's not moving, so we'll get close to 2 and close to 4, but we can't be at 2 and 4. There's no movement there. Okay. Now, what if I made this a slight change there? What if I said that my domain is t is greater than or equal to 0? How would that impact? Okay, so we have to test 0 to see what happens, right? So if I plug 0 into velocity, it may not be 0. Well, it's actually definitely not 0 because we know that it's not a stopping point. So this object is already moving by the time the timer starts. So if I plug 0 in for t, 0 minus 4 is negative. 0 minus 2 is negative. 2 negatives gives me a positive. So so we would have to make a change here, right? You guys said it, instead of a parentheses, you would put a what? Bracket. So just want to point that out there. Always pay attention to your domain. If your domain includes the 0, then you have to make sure, if it doesn't show up in your, when you solve for t, that means it's already moving. And so you would replace the parentheses with a bracket.
So it's why do you say it's parentheses go for the 2, 4?
Because at 2 and 4, the particle is at rest. So if it's at rest, it's not moving to the right or the left. So we can't include them when we say left and right.
Oh, okay. So what you did in the first problem?
Yeah. Okay, number 3. Given the equation x over x minus 3, find the equation of the tangent line. So that means we got to find the derivative, find the slope, the order pair, point slope form, okay, all that. Let's do something easy first. Let's find the order pair because we know we got to find the order pair. They didn't give that to us. How would I find the order pair?
Plug in the x
into the
original.
Yep, into the original. Good. The original function will give you your location, right? So we'll do f of 4 because that's something that we need. So I'll put that up here. F of 4. 4 over 4 minus 3 is 4, right? 4 over 1 is 4. Okay, so my ordered pair is 4, 4. Okay, I do want to get to my derivative, so I can get to my slope, so I can get and then write my tangent line equation. But to get to my derivative, look at how this equation is set up.
Quotient rule?
Gotta do quotient rule. Why can I not split up and use power rule?
Is it a minus?
Okay, yeah, right, because there's more than one term in the denominator, right? If there's more than one term in the denominator, then, sorry, if there's only one term in the denominator, then I would do power rule. But here, I'm stuck with quotient rule, no way around it. Okay, so let's find f prime. So here's a reminder of quotient rule, f prime times g minus f times g prime all over g squared. Okay, what's f prime? 1. G, no changes. F, no changes. G prime, what's G prime? 3. What's x minus 3's derivative?
It's 1.
Just 1. Yeah, x goes to 1, 3 goes to 0. All over denominator squared. Don't forget about that part for your quotient rule. Now I'm going to do some cleanup, but remember, when you do cleanup, do not touch the denominator. The denominator is at its finished state. It's the numerator that you have to clean up, and don't try to cancel out. Okay, we cannot cancel this out. Okay, so f prime is equal to x minus 3 minus x over x minus 3 squared. Okay, so here's my derivative. This is my slope formula. What would you do next? Get the slope. That's right. The original function gives you y value. Derivative gets you the slope. So -3 over 1 squared is -3. So we have everything that we need. We have our ordered pair. We have our slope. And then point slope form. Part B, find the equation of the tangent line to the curve when the slope is equal to -3/4. So how do we involve that -3/4?
70.
Good. So -3/4 doesn't represent the location. This represents the actual slope. So keep in mind what f prime means. F prime means slope. So what I can do is, obviously what we did from part A is we gave it a location. In return, we're asking for the slope. But we can also give it a slope and ask for a location, right? So just understand that, this feels a little bit more strange because we're used to just giving location, ask for slope, but we can also do the other thing where we're given the slope and asking, okay, where on the curve is the graph going to actually hit that exact slope of -3/4? Good, so I'll set -3/4, replace that in for my derivative formula, derivative variable. I'm going to solve for x. When I solve for x, then I can find my ordered pair. So this is kind of going backwards, right? I know what feels more straightforward is, okay, give it a location. In return, let's get the slope. But we can also go from this side of things. So does that make sense? Okay, so here, algebraically, we can solve for x. I'm going to cross multiply and see what I can do to solve for x. So divide both sides by -3, I get 4. Now I could take the square root and involve plus or minus, but I feel like we got to go through a different set of rules there. So I'm going to do this here. I'm going to fold everything out, bring everything over to one side, and just go through factoring. So 1 multiplies to be 5 and adds up to be -6. And -5. Solve for x. X is 1 and x equals 5. Now, what does this tell us? What does this tell us about when?
Tangent line hits at 2 different points.
That's right. That's right. There's 2 different places on this curve where the steepness is exactly -3/4. So we have to create 2 tangent line equations. Now, obviously, the slope is going to be -3/4 for both of them, but the location is going to be different. So how do we find each of these separate locations? Plug back into the original. That's right. Okay. So I have 1 point here. If I plug 1 in, I'll get 1 over 1 minus 3, which is -1/2. My second point, f of 5. 5 over 5 minus 3, so 5 over 2, 5/2. Now my slope is the same, right? They're telling me my slope is -3/4, so we're using that. So we'll just write 2 different tangent line equations.
So you don't use the original function, not like the derivative.
We use the original function to get the location because we already have the slope. So the only thing missing is finding the y value. So y plus 1/2 equals -3/4 times x minus 1. And y minus 5/2 equals -3/4 times x minus 5. Oh, so back here, if I inserted 1 back into the original equation, 1 over 1 minus 3 is 1 over -2, so -1/2. So if I put in point slope form, is y minus -1/2 times 4 equals -3/4 times x minus 1.
Those are both your answer.
Yeah, both my answers are here. Both my equations are here. It's on the back of your sheet too. Okay, let's try number 4. F of x equals cube root of x times 1 minus x cubed. We have 2 options here. What options do we have available to us if we want to find the derivative here? Yeah, we can do power rule because we can definitely expand this out and not have any nothing getting in the way. Or we can go through a product rule, f prime g plus f g prime. Okay. So either one works. Let's just practice with power rule. Okay, so I do, but you can definitely get. Now, if you go through product rule, power rule, we make it a difference. Our answer may look a little bit different, but they're going to be both correct. So I did product rule on my key, so I'll do power rule here. So first thing we do is we get our radicals rewritten as a rational exponent. And I want to clean up all my parentheses, so I'm going to distribute through. Now, if I multiply x's, what I do with the exponents? Add them. Yeah, so 3 plus 1/3 is the same thing as 9/3 plus 1/3. everything is nicely set up, I can go through power rule now.
So minus 1/3.
Now remember, we're subtracting 1/3 minus 3/3. So negative, negative 2/3, yeah. 10/3 minus 3/3 is 7/3. So I'm ready for my derivative, or I have my derivative. I'm just cleaning up, right? Okay, number 5. Here we have function, every term is separated. So guess what we can do for each term here? Power rule for each term, yeah.
So why is there a pi in there?
Right, so pi is, it's like 3.14, so it's just some number. Okay. So we'll keep that in mind, right? So what do you think a 4, what's 4 times 3.14? Is that still a number?
Yes.
Yes, so what's the derivative of a number? 0, yeah, so it's not 4 pi doesn't become 4, just become 4, right? I know pi is a symbol, but it's not a variable. It's just a number, so a number just goes to 0. Okay, so let's get every term ready so that we can find the derivative. Now, how can I clean up my first term to get it ready for power rule? Good, x to the 1/2, and I gotta push it up, make it x to the negative 1/2, right? So I'm going to do 2 things at once. I'm going to convert it to a rational exponent, and I'm going to move it up to the top because we cannot do power rule if the variable is in the bottom. Okay, I'll let you rewrite the second term. Every term is nicely set up for power rule. Let's go through power rule. So bring the negative 1/2 down.
Negative x to the negative 3x.
Good. Minus negative 1/2 minus 2/2 is negative 3/2. One-fourth minus 1 is
Negative 5. Oh, negative 3/4.
yeah, negative 3/4. Bring 3 down. Okay, 4 pi goes to a 0. Good. 6.5x becomes 6.5. Negative 1/2 and x, negative 1/2 and 2 cancels out. The negative does stay, so 5/4. Bring the x down, share the same space, that's the 4.
You bring back to like the fractions.
Right, so I don't want negative exponents in my answer, so we want to make sure that we push the variable back down to the bottom as a cleanup stage.
So you wait to help us.
Yeah, I'll do a help session tomorrow. morning, going over particle motion. I'll send out a reminder about that. And I think the bell's gonna ring a little earlier today because we have map testing. We have an extended advisement. Okay, come get your phones.
You guys are. You didn't start something like what? Remember Roger? That was.
Yeah, appreciate it. Thank you.
Yeah, I hate to see that, I don't want to. Yeah, I really might be for Phillies. We have a good sports system. Maybe we'll go together. Yeah, cool. But no, the Dolphins are really good though. Well, it's good to the Dolphins. The Dolphins are looking good. They're looking like most scary. Like Tua had like 4 yards or something. Yeah. That's those play the Ravens.
Then everyone laughed.
We gotta get fixed up.